Here is our complete PyTorch example. So this is taken by machinelearningmastery.com. This is a great source for examples and tutorials on machine learning, and it was translated to PyTorch and modified to a simply fully connected layer by Professor Shura. So here we are importing our libraries. We will use NumPy, PyPot to plot, PyTorch, Torch Vision to have access to the MLfAS dataset. Then here we are defining the neural network model, like we explained before. We are defining 2 layers, and we are using the ReLU activation after the first layer. So the input of the first layer, it will be the number of pixels. The output of the first layer also the number of pixels. The input of the second layer is the number of pixels. And the output of the second layer is the number of classes. Here we are setting the batch size for training, batch size for testing, and the number of classes. And the 10 classes are according to each digit, and we have digits from 0 to 9. At this point here, we are loading our data set using a data loader. So this is how we are doing this. So the normalize arguments, they are the mean and standard deviation. And here we also have now a train set and the test set. This is how we loaded our data set. Then we are also printing the shapes and the types of the data inside the data set. So here we're just doing an example, and we will plot 4 images. So we have this from the training set from 0 to 3, and this is what we are doing here. We are plotting these 4 images like here. So this could be a 1, a 7, a 9, and a 7. And we see that's 1, a 7, a 9, and a 7. So this is the type of the train. It's a float tensor. Type of the target. This is the input. This is the target. Here we have our shapes, like we discussed before, and here we can see all the classes of our target. So this is what we did this part here. Then we are doing that the number of pixels is the shapes, so it's 28 times 28. So it's the shape 2 and shape 3. So we remember that we have 100 was shape 0, then 1, 28, and 28. And this is what we are doing here. Then we are going to flatten the image, so we want not a 2-dimensional array 28 by 28, but we want a flat. And we can also, if needed, we can also normalize the inputs from 0 to 255 or from 0 to 1. But in this case, we are not doing this. It's not needed. Then we move on to build the model. Our model is this dense net that we defined here. We are defining our loss function that we are going to use the cross entropy loss, and we're defining our optimizer, and we're going to use the ADAM optimizer. Here we are training the model. We're going to use just 10 epochs, just for a short example. And here we are doing the standard way, so we get the predictions, giving the input from the training data set to the model, and we have a loss, which is the predictions and the target. Between we compare the predictions and the target using the loss. Then we use the zero grad, we use the backward, and we use the optimizer step is we're going to see, all PyTorch models. This is just a way to calculate the duration of the optimization, and then we'll move to the evaluation of the model. So again, we will see the loss on the test set calculated. Here we can save our model, and lastly we can do some inference. So it will predict an example in the digit test image, and we are going to see what image we are going to infer, and then we want to know what the model predicts. So this is when we run. This was the first part that I showed before. Now we see that we have the shape of the training set. Now it's 100 times 784, and we see the shape of the test, and it's 10 and 784. So this is the 28 times 28 pixels, and this is the number of images. So we have 100 in the training set and 10 in the testing set. Here are the losses for the training, and we see that it starts at 2.25 and it ends at the last 0.98, and it took 0.1 as the duration of the optimization. So it was very fast. And then we are going to give an example. So after the model is trained, we take an image, for example, from the test set, and in this case the prediction was correct. And here we can see the probabilities of all the classes. And why it chose 3? Because we see that this is 0, 1, 2, 3, and 3 is the largest number of our of the probabilities here. So this is not actually the probabilities, because we use this cross entropy. So the probabilities here, they don't go from 0 to 1 and then don't sum up to 1 in this case. But we could also convert this using, for example, a softmax, and then we would have these as probabilities. And so that's it. First we saw how we would design our model, going through some important points, and here we went through the whole model and saw the results.